Okay, so we were talking about various aspects of quality so far. We looked at the BNB model and the importance of quality assurance, things like that. So today we're going to look at one aspect of software quality assurance, trying to understand what is software quality. Okay, so we will move on to the actual working of the quality assurance side, like say what is black box testing, white box testing. There is also a talk about the gray box testing, something in between black and white. And also we need to understand the specifications, like there are certain standards on where we can maintain quality. There is a ISO standard, there is IEEE standard, then there is also things like CMMI standard. So as software engineers, we need to know these standards, right? They are not just for testing, right? This is not for software testing. This is for the entire organization, because we'll see the difference between the QC and QA. The whole organization should be aligned towards assuring the quality. Otherwise, you can't build something and then test. Before you build it, you need to make sure you follow certain steps, right? Only then you will get the right product coming out of the at the end. Right. So today's question is how to answer this question. Is this a good quality software? Now, this might be when it comes to you buying a piece of software, right? Let's say I want to buy a software to type letters, word processing software. I get the software and then I have the question, is this a good quality software? How do I know? Or let's say a customer want us to build a software. So let's say they have they want an inventory management system. They are a pharmacy. So they ask us to build the software and then we build it. When we supply the software, they ask the question, is this a good quality software? How do we answer that? Right? So it's not very simple to answer, isn't it? You can't answer that question simply because there are so many things involved there. First of all, we have to define quality. What is quality? Right? So to answer that question, there are two things we need to refer. One is called the attribute of the software. The other one is called the process of the software, or rather development process of the software, right? Two things. Now, first thing is called measuring the attribute of the software. Now, we are looking at size of the software, for example, how much resource it requires, how long does it take to process something, things like that. Those are called attributes. So you measure that and say, okay, according to a certain standard, your numbers are good. Okay, so because of that, we say this is a good quality software, right? Now, this is called quality control. So you are controlling the attribute of the software. That is one way to look at it. The other way to look at it is monitoring and controlling the development process of the software, like how this software is developed, right? So you look at how the software is developed and then you can give a comment on whether it is a good quality software or not, right? Now, how do you say that the process is good or bad, right? So that is where you have to compare good processes versus bad processes. Okay. Now, this is called quality assurance. You see, there are two things. Quality control is looking at the attribute of the software. Quality assurance is looking at whether the software is developed properly. Now, this can be very directly attributed to American car manufacturing industry. or automobile industry, because they not only manufactured cars. In the early 60s, the world's largest three vehicle manufacturers were in American: Ford, Chrysler, and GM, General Motors. These are the world's largest, okay, automobile manufacturing companies. So, and then in the 60s came the Japanese automobile industry, like Toyota, Nissan, Daihatsu, Honda, companies like that. So if you look at the way they built their vehicles, well, you can't say anything bad there. All the vehicles were good. But if you look at the consistent quality of the vehicle and also per unit cost, right? Japanese vehicles were far ahead. Now, if you look at the attributes of the Japanese vehicle versus attributes of the American vehicles, there is a huge difference, right? So American vehicles were very large, or rather bulky, and the famous term was gas guzzlers, right? Meaning they run a minimum kilometers per liter of petrol. Whereas if you look at Japanese vehicle, they were very compact. They are not massive. They are very compact, and they do very well when it comes to fuel consumption. And also other things like consistency in quality. How long does it take to break something? Yeah. So if you look at the American cars, they break fast compared to the Japanese vehicles, which are very reliable. So someone did a research to find out, okay, what is going on? Why American cars are like this? Why Japanese cars are like this? So they realized Americans were more focused on the quality control. What does that mean? Both of these companies, actually both countries were using production line, which was introduced by Ford, where before Ford, there were teams of people building a car in a group. So there's one group building one car, then there's another group building the second car, another group building a third car. Likewise, Ford came up with a mechanism called the conveyor belt, or the it's a continuous process, right? Where in the beginning you have a structure, a team of people building the structure, and then it goes to the next team. Those team may be fixing the doors. Then it goes to the next team who will be fixing the engine. Next team will be fixing the wheels, like that. So at the end, what happened was the quality was improved, because if a team is fixing only the engine, after some time, when they work for months and months, they become experts in fixing the engine, and they can do it faster, isn't it? So this is called specialization. And in when the car comes out, they have another team who is looking after the quality of the car. So they check each and everything. They check the doors, the engine, the wheels, and everything. And that is quality control. And then they say, right, okay, this car is good. And then it goes, right? Whereas the Japanese industry was more focused on the quality assurance. So they, of course, have quality control, but they also look at quality assurance bigger than the American companies. So their concept is, if you give the right material as the input to any process, you get the right output as the condition, right? Which means starting from the beginning, so they source the best raw material. And at every stage, you check the quality. You do the quality control, not at the end. You do the quality control at each and every step. And in fact, in Toyota, they had a line like what we have in our buses, a line where we can pull in to ring the bell. They had a line in the Toyota production line. That means if anybody, it doesn't matter whether it is a manager or a technician or anyone, sees a problem in the production line, they can pull the string to set up an alarm, or rather to sound the alarm. Okay, so that is for anybody. Now, if you stop the production line, that's a big problem. So entire company is getting halted. So nobody wants it, right? So everyone wants to do their best to make sure the process that they are doing is perfect. Now imagine when the whole process is quality controlled, not just the end product, what are you getting at the end? You get a high quality product at the end. So while the American production line, at the end, you have a big team waiting for the car to come out and then test everything. Japanese production line, there is only one person. No team of testing, no need of testing, because the car is tested at each and every stage. So you don't have to test it again at the end, right? Everything is tested. So this is the difference between quality control and quality assurance, even in the software business. Now, there may be a company who's building the software and then give it to the quality assurance team or the testing team for testing, not quality assurance team. Actually, it is a testing team. And that is one way to do it. Or the whole company can start from a proper process. So you go from one step to another step, there is a process, right? You go to another step, there is another process. So if the process is great, if the process is perfected, at the end, you are going to get a high quality software, right? Just like the Japanese vehicle industry. Now, if you look at the statistics of this quality control, quality assurance process, now this is coming from 2002. It's old, but the numbers, I suppose, are the same. They remain almost the same. So it says experienced programmers inject one defect per line of code, 10 line of code. So if an experienced programmer write code, there may be one issue per 10 lines of code. Lock mean line of code, right? It doesn't mean that every time they write 10 line, they introduce a code, but that's like an average. Okay. So out of this defects, if you can find out 99% of those defects, if you can find out, that means if when the experienced programmer write 1 million line of code, it will only have 1,000 bugs. You understand the number? So this is for experienced programmers, okay? Imagine amateur programs, how many lines of code they will be writing and what is their defect rate. Their defect rate may be much higher than the experienced programmers. So we need mechanisms to make sure our defect rate is lower. Now, how do you do that? Two things. Process will not help us, right? Now, you might have the best process, but if you have amateur programmers building the software, you will end up having lots of defects, right? So you need to continuously train the programmers, developers on best practices, how to write code with less defects. So it's a continuous learning process. Okay. So here comes the next definition, list of definitions on what is quality. So we ask the question, is this software good quality? But then here are some definitions. What is quality, right? Quality is fitness for use, Duran says. Those are the authors, by the way, in the bracket. Quality is fitness for use. And another person says quality is most profitable product line we have. So if you have multiple products and the most profitable lines are the good quality product. Or somebody says quality is free. Now, what does that mean? Quality is free. Quality is free because if you do some extra effort, you get a high quality product. If you don't have extra effort, you get low quality product, right? So it's a direct input to what you give. And then the next one is also interesting. It says quality is compliance to a standard. Now, what does that mean? So if you have a standard and if you comply to that standard, we say, okay, your quality is good, right? Or our glass says quality is a degree of excellence. Now, what does that mean? Degree of excellence. So 100% is 100% quality. 99 means 99% quality. That's what it says. It's a degree of excellence. How much quality? Is it 100%, 90%, 80%? What is it, right? And then Next one, it says the degree to which a system or component or a process mean. So when you say degree and a percentage, what do you mean by that? So specified requirements or certain expectations, like say IEEE 610. So there's an expectation. So out of the, let's say IEEE 610 12 1999, how many elements you are complying with? So that can be the degree of excellence, right? And then from ISO 9003 has another definition. It says the totality of features and characteristics of a product or service that bear or its ability to satisfy specified or implied needs. That's a big definition. But basically what they say is in the above. They say how many features are there and what are the characteristics of these features, right? And so you have a specification, and to that specification, how aligning are these features? So that's quality. Now, who's responsible for the quality process? You look at the project manager, right? We are talking about the overall, so the general purpose project manager. So the project manager need to do three things. One is deciding, two is selecting, third one is assembling, right? So number one is decide which quality factors are vital for a particular project. So you see there were so many different definitions here, right? So which one are we going to take? The definition for our project is the first one, deciding. Say as an example, high reliability and maintainability. So is that what we are going to look at? So that is a decision the project manager to make first. Number two, select standards and procedures from a quality manual that are appropriate to meeting the quality goals. Okay, so now first is to deciding the factors. Number two is to deciding the standard. Now here we saw two, right? IEEE 610 or ISO 9003. There is also other areas like CMMI and stuff like that. So you have to select one. Okay, like the use of complexity metrics to check maintainability. So there are charts and graphs and whatnot. So you need to select something. So while you're developing, you can say how much are we compliant, for example, to these metrics. And the last one is assembling, right? So after you select and decide, you bring them to the ongoing project. Assemble these into a quality assurance plan for the project, right? So then the PM has to inform the staff or everyone in the team, okay, this is our quality standard and this is our quality factors, right? So in order to get there, there are procedures, standards, and who's doing what, when they do it, everything must be clarified. So this is about quality assurance. Remember number two. So there is also quality control coming in, but now we are spending time on quality assurance. All right. So these are the tasks. And then that's project manager, by the way. So there is also, remember in a developing of project requires many different people, right? So PM is one, that is project manager is one, but there is also a QA person or a QA team. In fact, there's a QA manager, quality assurance manager. So what is his or her responsibility? Number one, to create end-to-end test plans. Now here comes the quality control, okay? And then execute the plan, and then to manage all the activities in the plan. So that is the role of the QA person or the QA manager. Okay, so pretty clear, right? So there is some work for project manager, and there is some work for QA manager as well. two different roles, and both are very, very important. Right. Now, talking of this, there is a very famous a triangle that we always talk about. This is called the McCall software quality factors triangle. Yeah. So he spoke about three things when it comes to quality factors. Now, what do you mean by quality factors? Quality factors are the variables we are looking at, because we need certain variables to compare, isn't it? So he grouped them into three: product revision, product transition, and product operation. Okay. And under each section, he also broke it down into further areas. Now, if you take product revision, for example, maintainability, flexibility, and testability. So now if you take one of those, let's say testability, right? You can have a number there, say 1 to 10. And then you can then grade your software according to that number. Testability wise, our software is on number 6 or number 8, right? That is one way. The other one is what the client is asking. So client might say, look, I want the testability index to be 9 or 10. If 10 is impossible, okay, I want 9. Actually, testability should be 10, 100% testability. Okay. Or maintainability. What is the number the customer is asking? So we can say, okay, customer is asking 9, we are 6. So we have 3 more to work on, right? So this is a good way to compare where we stand when it comes to quality. And on the same line, transition, portability, reusability, interoperability. This is about how you can connect this product to other systems, like integration, for example. Is it easy to integrate with other platforms? And the third one is operational. So you have correctness, reliability, usability, integrity, and efficiency. The product operation is also very, very important. We can't say one is more important than the other. They are all equally important. And like I said, this is one way to compare the qualityness of the product. Remember our first question, is this software a good quality one? Now, to answer that question, we can use McCall software quality factors. So let's look at the operational quality factors, the one at the bottom, right? I said very important. So we have correctness, reliability, efficiency, integrity, and usability. So what do you mean by correctness in that? The extent to which the software meet its specification and meet its user's requirement. Now, this we go back to the client side. And remember, the process is there is a customer talk to the marketing team and then gives the deal, and then the BA team sit with the customer to understand the requirement and then translate that to the development team. So now we have the customer, we have the development team, or let's say BA is in between. And we as developers, we build the software. So how much compatible are you with the BA requirement and the customer requirement? That is called correctness. So according to the BA, we need to have 100 features. And according to the developers, they have built 60 features. So we can say we are 60% done. So we have a number now. When the client says, okay, how much more to do? We say 40% more to do because we have done 60 features. All right. And then number 2, reliability. What does that mean? The degree to which the software continue to work without failing. Right. There is also something called MTBF, mean time before failure. You can see that in electronic gadgets. Let's say, if you take your phone, for example, there's an MTBF. If you take let's say, a mouse, electronic mouse, it has an MTBF. It says 10,000 is MTBF, 10,000 hours or 1 million hours. So that means after 10,000 hours, the system might break. Or the other way, it will work 10,000 hours without any problem. Right? So that's reliability. Now, can we say that to a software? Not very straightforward, but what can you guarantee? right? So reliability comes from testing. So you can say, okay, we had 100 features. Each feature was tested 10 times using 10 different cases. So now it's about 1,000 cases. So out of the 1,000 cases, it failed 800 times and we fixed it. So again, we tested 1,000 times, it worked. So we are sure that the reliability is tested, right? Now, what if there are other ways of using the software that we didn't test? Well, then we have a problem. So the reliability is about how much guarantee you can give about your software. Third is called the efficiency. Another word, performance. Both are same, efficiency and performance. So that's about how much resources the software needed, like processor speed and the processor time, how much RAM memory, how much hard disk space, how much networking it requires. These are the resources, right? So as an example, if you run Chrome browser for development work, when you open multiple tabs, you will realize after a while your Chrome is going to take up all the resources in the computer. So the computer becomes very, very slow because of Chrome, right? So performance-wise, Chrome is a bad product then, isn't it? So we can talk about our product also in the similar line. Okay, what happens when we run the software for 10 hours? What happens when you run our software with 10,000 people? So what is the performance issue there, right? Or if it is an online software, what about 1 million people coming at the same time? Let's say like a Uber kind of application. Does it work? When it is going to crash, right? So those are the questions coming under performance and efficiency. And then the integrity. What does that mean? Truthfulness, we can say, right? The degree to which the software enforces control over access to information by users. Access to information, that is important. Now, what if, say, as an example, you're storing the user's password without encrypting in the database, and somebody crashes your computer and then get hold of the database, which happened in multiple times. Sony PlayStation, the online Sony PlayStation database was stolen once, and they lost about, I think, 60,000, 70,000, or was it 600,000? I'm not sure about the number. They lost the number of user credentials, including their credit card, everything. Okay. Luckily, the data was encrypted. So they said, we lost the information, but don't worry, it is encrypted. So no one can get it, right? Because the decryption was in the code and the code is not stolen. So no one can get the data back, right? So what is the integrity of our software? And if you remember recently, one of the leading bank in Sri Lanka had a serious issue with their mobile application, right? So someone could take over your bank account using their mobile application. There's no hacking required. It was purely a software bug, the developer's problem. So it's an integrity problem. Yeah. And the last one here under the operational factors is the usability. How easy to use the software? Now again, how do you give a percentage? Can I say 10% usable, 90% usable? And what does that mean? Of course, as we move forward, I'll show you there are certain ISO standards which we can bring in here. So according to the standard, we can give answers to each of these factors, because these factors don't make any sense if you can't bring in some standard. Okay, otherwise they're just numbers and words. So the next one from McCall product revision, the McCall's thing is product revision quality control, right? Or factors rather. Three are there: maintainability, flexibility, testability. So what do you mean by maintainability? The effort required to find and fix a fault. Maintainability is that, meaning if something goes wrong, how long does it take someone to find the problem and fix the problem? Now, why does it matter? Now imagine there are amateurish software developers building the product and they don't have any technical documentation of the system. And later you find out there is a major bug now in calculation or whatever, right? Now you need to find out which function is doing this calculation. How to find it? You will not be able to find it if the product documentation is present, not present rather, right? And this was very evident even in the final year presentation projects also, like if something goes wrong or if the supervisor gives them a suggestion, it is very difficult for them to go back and find the issue and fix the issue because it was not designed for maintaining, right? So when you say designed for maintaining, you need to have a certain standard on, let's say, software, what do you call it, documentation, right? I'll show you in a minute after this as to there are certain editors, for example, allow you to automatically generate documentation. Yeah. So that directly allows you to do the maintainability. Okay. So that's number one, maintainability. Number two is flexibility. What does that mean? The effort required to change the software to meet the changed requirement. Now, we talked about a couple of models, right? There is a waterfall model and there is agile model when it comes to software building. Now, according to the waterfall model, you build something and then you go to the next step and the next step and the next step. Now, in the real world doesn't work like that, right? So you build something, you give it to the client, and the client comes back and say, look, we need a change, right? So what do you do now? Right? Can you say, sorry, we can't do that? Or wait, we can change it, right? So if you have a flexible way of building software like Agile, for example, you can accommodate that change. If you are not flexible, you can't accommodate changes. So that's a big question mark when it comes to customer management, or rather their request management. And the third one here is testability. The effort required to test the software effectively. So how much effort is required? Now, this effort must be minimal. Why is that? There is a concept called test-driven development. So if you incorporate that as a quality assurance process to build your software, so from day one, you're building your software in a way to test it, right? So your code has the real code, the function that you have written, and another function to test that function. So you are basically writing two functions. First, you write the testing function, right? We call it the test. And of course, when you run the test, it fails because you don't have your real function. And then you write your real function and you run again. Okay, now it passes. Now you don't stop there. We go and do something called refactoring. We improve our code after that. So when you develop software like that, where you first write the testing code and then your real software, after a while, right? After, let's say, a month or two, you will have many cases, test cases in your software, right? Large number of test cases is already there. So all you need to do is press one button and your software is automatically tested. That's why I said the effort should be very minimal. Imagine you don't do that. You just go on writing code and code and code and code. So when it comes to testing, the testing team has to employ the same amount of time to test it, isn't it? Or actually more time testing. So that is why the effort requires much more if you don't plan it ahead. And these are all quality assurance work, isn't it? Where we have to do the planning before we do the product, or rather coding. And the last one, the third one, is transition quality factors. Now, what does that mean? One is portability, then reusability, interoperability, and then security. What do you mean by portability? The effort required to transfer the software to a different hardware or software platform. Now, when it comes to especially web-based applications, we generally have three servers. One is called the development server or the dev server, where all the developers will be pushing their code to the dev server, right? So let's say I use my laptop to develop my code, and at the end of the day, before I go home, I push the code to maybe to a code repository, and from there to a dev server. Okay, so when it goes to the dev server, the QA team or the testing team can use the dev server to do their testing. Or maybe we push that from dev server to, let's say, to a staging server, right? And the staging server probably is the one our testing department will be using for testing. So dev server is probably latest code, but then we push good code or rather working code to the dev server or the staging server. And once the QA gives okay from the staging server, we push the code to the live server. So we don't ever push directly to the live server, because if something goes wrong, you're breaking the entire system. So that's why generally we have three servers, but minimum we need to have two servers, staging server and the live server. Okay, sometimes each individual person runs the system in their laptop and they push it to the staging server for others to, maybe the testing department to do the testing. So now if this is the case, how is the installation of the software coming into play here? So is it very difficult to install into another server? Like there are a lot of configuration, for example, right? Now there are many different tools available. One is called the virtual machine way of doing things, where you install a virtual machine image and then you install the software to that virtual machine image. And then if you want to take a copy, all you need to do is take a copy of the VM and install that into another machine. That's the older way of doing it. There are different ways. This is called container-based development. One of the most famous container is called Docker. So in Docker, it's actually a VM, but a very lightweight. You install that into your laptop and you get a development environment very similar to your server environment. And then once you're done, you push your code and it goes onto the server. And if you want to make a copy, all you need to do is pull the Docker image and then install into another machine, just like the VM, right? So if your company does not use containers or VMs, then it will be very difficult to say you are portable, right? And then reusability, what does that mean? The extent to which the software or component within it can be reused within some other software, right? That is, you have certain components or you have certain things in your software. And let's say you have a graph module, right? Where you give data and gives you a dashboard with graphs and whatever. And you want that module in another piece of software. So how easy it is to take something from here and load it in there. So there are concepts like component-based software development. If you use that, then you are basically building either component or a module, and it's very easy to take one module from one software and take that into another software, right? Again, these are things you have to do before starting the code, beforehand, long before, yeah? And then interoperability also very similar to reusability, but here we are talking about the software talking to another software. We call it integration. Say, for example, I want to get the latest exchange rates. How do I do that? Right? I need to get connected to the central bank of the country or maybe another currency rate provider somewhere out there. And how easy it is for me to integrate. What is the mechanism? Am I going to use XML, JSON? Am I going to use REST, XRPC? What is the mechanism I'm going to use, right? That's interoperability. Now, this decision comes from the framework you are using to build your software. Different software frameworks have different ways of communicating. Now, for example, if you take Microsoft platform or C#, for example, They prefer WSDL, it's called. It's XML based. Actually, the technical term is SOAP, SOAP, where you integrate system using the SOAP mechanism, passing up and down XML files. And there is another mechanism, of course, Microsoft supports that as well, called the REST mechanism, where you are using the HTTP protocol to do the communication, right? So we need to figure out, okay, which platform we are going to use and which interoperability mechanism we are going to incorporate. And the last one is security, right? The extent to which the software is safe from external sabotage that may damage it and impair its use. Now, this is a very common thing when it comes to online software. Okay, like how easy it is to send it's called injection attack, right? Through a form, someone can send some information that can break our software, and they'll have full access to our database or to files, right? So how easy it is. So this is actually not much to do with the language or the framework. It is about how you implement this on the server, right? So how secure your server is. Is it running on Windows or Linux? If Linux, then what is the mechanism? What do you have on the public folder? What do you have in the private folder? Stuff like that. So again, this is part of the QA process, right? So we are looking at the factors that gives us the ability to give a rating or to answer that question. Is this software good quality, right? Now, here's a summary of the whole thing that we discussed, right? Correctness is the criteria to check the factor correctness. The criteria is traceability, consistency, completeness, right? So we need numbers here. How many features are there? How many are complete? Then we can talk about correctness. On the reliability factor, we are looking at error tolerance, consistency, accuracy, simplicity, right? How many errors that you tested, how many more errors that can happen. Again, numbers. And then efficiency, execution efficiency and storage efficiency. Again, numbers. How much resources do you want? And then integrity, access control and access audit. Do you have an audit mechanism in the system, right? Do you have a role-based security, meaning admin is a role, user is another role, supervisor can be another role. Are you recording all the activities done by each person, right? And then the usability. So under that, there are a lot of things. Operability, training, communicativeness, input-output volume, and the input-output area. So mostly to do with how easy it is to use. Now, we will when it comes to software building, we will be looking at something called a three-tier architecture or a client-server architecture, where we have an API server on one side, we call it the backend. Then we have a front-end computer doing basically communication with the backend. So that's where the input-output volume is coming in. How much of data you're sending to the backend to get things done, and how much of data coming from the server to you in the communication, right? And then maintainability. So under that, we can talk about the consistency, simplicity, conciseness, modularity, and also self-descriptiveness. What does that mean? Basically, each module must have its own information, rather documentation, right? Self-documented, we call it. And also, they should be modularized. You need to have modules. If you take Java, Java uses the word package, right? One package is one module. And every class, every method can be documented. When you do that, you can generate documentation, HTML documentation, beautifully done HTML documentation for every module, right? So that improves the maintainability. So the next one is testability. Simplicity, modularity, instrumentation, and again, self-descriptiveness. So very similar to maintainability. So if you have designed it in a way your testability is there, then your effort is very less. And then comes the rest of it, the flexibility. Flexibility is about have you built it according to modules? Also, generality. What does that mean? Do you have general purpose modules? Expandability. So, can you bring other modules and expand your system? Again, we have self-descriptiveness, documentation, and the portability. Is it designed according to modules? Self-descriptiveness, machine independence, software system independence. So that is portability, meaning can I run this software on Unix as well as Windows, right? Can I run it on Intel processors and ARM processors? Can I run it on other platforms? So that kind of portability, okay? And then reusability, generality, modularity, system independence, and also machine independent. So very similar to portability. Here we are talking about being able to take a piece or the whole thing and then using in another aspect or another area. That is reusability, right? And then comes the interoperability. What does that mean? Being able to integrate with other platforms and systems. Modularity, communication, commonality, and also data commonality. That means we are communicating with other platforms. So how simple or how easy it is to do this communication. Remember, I talked about SOAP and REST, and there are various other ways of communicating with other systems. So does it support it? And this generally comes from not just the language, but the framework. Right. Now, talking of this self-descriptiveness, let me show you quickly what I mean by that. Okay, so here's my NetBeans IDE. I'm trying to create a Java program. So I already have something here. So I have a package and then I have a program, or rather a code here. Right. And you can see I have some things already, right? So certain sections are already here. So this little piece called the doc block is what we are going to use, right? So when you have that, now for example, here I don't have a doc block. So all you need, it's very simple to do. So all you need to do is put slash and double star and press enter. There. The at param comes automatically. Okay. So I can say main function to test the code, right? Generally, we give a space between the explanation and the rest of it. Now, if you look at the Java documentation itself, you will notice there are so many things. At param, there is a at author, for example. So there are a lot of stuff that we can use here. So up here in the beginning, we have the whole the common section for the entire program. And then for this is the explanation for the class. This is the explanation for the pattern 1 function. This is for pattern 2 function. And then I just added another one here, pattern 3 and whatnot. So let's run this code. Nothing will be shown. The documentation block is not shown on the output window, right? So it just runs the code and show us the output. That's it. And for me to generate it, I need to go onto the left-hand side, do a right click and say, generate Java code. When I do that, it runs something here. As you can see here, it says build patterns. Something going on. It'll take some time. Okay, 50% done. Okay, still working on. Once that is done, you will see the documentation also as part of your project here, right? Okay, what happened? Warning, generating Java doc, build success. Okay, so let's look at project file, dependencies, source. Pattern Java, all description. Okay, let me go into that folder and see whether I can find a documentation. Okay, it is generated. Let me show you the documentation now. Right, as you can see, this is the HTML file, which is inside target site API docs, right? That's the folder. And this is what is generated. So it's beautifully generated HTML file. So I can go through the sections here. So I'm inside the package. So there is a class called patterns. When I click that, it gives me whatever that I put in there. So notice I typed this, right? Main function to test the code that is there. And under the class called patterns, I have these methods, pattern 1, 2, 3, and main. By the way, they are alphabetically sorted. And the description is shown here. These are all methods, so these are static. I can also sort it out accordingly. Right, I can get more details. So this is for each method. I have details, right? Triangle parameters, all that. So basically, all I need to do is just do a right click and just say generate code. So imagine when it comes to maintenance later, after you give this project to somebody else, and when they wanted to find out, okay, what does pattern 1 do, right? He doesn't need to go through the code, right? So you can go through this documentation where it says triangle pattern, and I don't have any more details here, but we can do that. I could have added more text to it, what the parameter does, and so like I said, you do this in the beginning of the project, not at the end of the project. Now, developers are very lazy when it comes to writing instruction manuals or documentation. So because of that, the IDEs have given us the system to do it very easily. So all you need to do is just generate that using your IDE, right? And it's pretty simple. Yeah. So once you add it here, it will give you what the product is. So here I can say, now let's say I'm adding another one, right? Java text pattern generators. Right. I go back and say pattern, generate Java doc, and there it is running again. Now this time it will run fast because I already ran it once. There, it ran very fast. So if you go back to the documentation, let's reload. The package, patterns. So that's how you generate. So you see, first time when I run, it took a while, but when you keep running it, it runs very fast. Yeah. And also, if you learn object orientation, you heard of inheritance, right? Inheriting from the parent class. So these are the inherited things from the parent class called object. Hash code, get class, finalize, all that stuff, right? So we may have not used it within our system, but inside we may have used all because we inherited that. So that's something I want to share with you. Let's get back to the presentation. Talking about the ISO. Okay, so what do you mean by quality management? So we were able to answer the question, right? Is this software good quality? Now, how do you manage the process? Remember, you can't have different processes for different companies. And then you can't rig the process and say, look, our process is the best. There is nothing like that. So there is an internationally approved processes available. So that is what we should say. Like say, for example, in Sri Lanka, ISO 9000 is a very famous process for companies, right? They say like even SLTC, we are a ISO 9000 compliant organization. Now, what does that mean? It means we have documented all the processes at the university, from how to register a student to how to obtain results, everything, there is a process. So if the staff members adhere to the process, then our output can be predicted. That's what it says. When it comes to the software here, we have a ISO 8402. Yeah. In this, we have something called the quality vocabulary. Vocabulary is words, right? So what does that mean? The totality of features and characteristics of a product or service that bear on its ability to satisfy stated or implied needs is quality. So this is the ISO definition of quality. What does it mean in simple English? Totality of features and characteristics. So how many features you have, how many characteristics you have of those features, right? And how many of that is satisfying the required the needs from the client. That is quality. Very simple, isn't it? In simple terms. So it shows, it basically tells us about numbers, right? So when you say how many, we are talking numbers here. And then let's look at management of an organization. How management works in an organization. The managers, there are three levels. Strategic managers, or we call it strategic level management, tactical level management, and then operational level management. So strategic level managers are concerned with the direction of the organization relative to the environment. If you take SLTC, there is a board of directors. They don't come for classes and then, they don't do, they don't check whether the grass is trimmed and whatever. So they look at strategic level. Okay, how can we make this campus top 10 in Sri Lanka, right? How can we bring in international, let's say, quality guidelines to Sri Lanka? That kind of thinking. So it is concerned with the direction of the organization. If you take a software company, it's like, okay, how can we become, let's say, most friendly software organization in Sri Lanka? How can we be giving the best satisfaction to our customers? So that kind of strategic level. Or in a financial term, how can we become a billion-rupee company in the next 10 years? So that can be sort of a strategic level. Tactical level is how do you implement that strategic plan? Now, let's say if the board of directors say we need to be making, let's say, 100 million within the next 5 years. That's a strategic level, let's say. So the tactical level is coming to the CEO, right? Or we call it C level, Chief Executive Officer, Chief Financial Officer, Chief Information Officer, Chief Technology Officer. So they need to now run that requirement, 100 million rupees within 5 years. How to do that? Okay. So they will figure out, okay, in order to do that, we need to have this number of customers paying this number of money to our software. So to do that, we need this number of staff members. Each staff member requires this number of computers, tables, chairs. So tactical level is about getting those numbers right. And the last one, operational level, are like the managers, right? So they are looking at day-to-day operations, weekly, monthly, annually, what is going on. Like if someone is leaving, okay, what can I do now? How can I get a new person? Or how do I manage training to our staff? Or how do I manage deployment to, let's say, a server in the US? So that kind of thing, all right? So these are the management operations at the levels. Now, with that management level, if you look at our own area, the quality management level, okay? This is a V-shaped thing again. There are lots of things going on around the world. And with all that, how do you keep improving ourselves, right? Remember, we had quality control and quality management. So in this very complex world, how do you manage this whole thing is the question we have, right? So on one side, we have rapidly changing technology. And then on the other side, we have international competition. So I can give an example. Let's say we learn Java and we go and join an organization where, okay, Java is a bad example because Java will be there for a long time. If you take something else, let's say COBOL programming language. You learn COBOL programming language and you go and join a company, nobody's using COBOL programming language. Or if you take JavaScript, a good example, JavaScript is in fact, it is the most widely used language in the world right now because you can use JavaScript for backend development as well as for front-end development. But then again, you don't use pure Java. You use some flavor of framework. Let's say React is a JavaScript framework. Or if you take Angular, another JavaScript, completely different JavaScript framework, right? Or if you take jQuery, is another one. So there are so many different things under JavaScript. So if you master, let's say React, and then React is coming from Facebook, and let's say Facebook decided to discontinue React next year. Now what do we do? Our learning of the language will be wasted, right? And then, okay, imagine there is a new language now coming up, much better than JavaScript. Now what do we do? So there's a language called Go. It's called Golang, again from Google. Supposedly very fast, multi-threaded and all that stuff. So now if you don't know Go, we can't find a job. Now what do we do? So things like that change all the time. Okay, that's for most of the developers and also for the companies. If the company bet on a certain technology and they build all their product on that technology, and if that technology expires, now what do you do? Right? On the other side, international competition. So is it cheaper to go to India and find a team and then build your software in India than building it in Sri Lanka? Right? Is it expensive? Is it better, faster? Right? So people ask this question, okay, can I build this in, let's say, in Vietnam? Can I do this in South America? Right? So there's a huge competition going on. And then if you look at the customers, they keep demanding lots of things. They want faster, more easy to use, multi-platform application all the time, right? So lots of demand coming from the clients. And then, yeah, they can demand, but then how do you convert that into value to the customer? So is multi-platform really a requirement, right? Now, how much money-wise, how much are we talking here? Or if you look at platform-wise, should it run on Windows versus Linux? What is the value there, right? So with that comes our goals. What are our work agendas, our work goals? In order to, let's say, build something, we have a certain goal. By, let's say, within 6 months, we need to build this particular software, right? And then to do that, within the organization, you need systems and processes. That is where we have this quality assurance part coming in, ISO systems coming in, right? And then how do you manage the behavior of the people? Because processes are one thing. If the people don't run those processes, there is no point having a process, right? So you have to manage the behavior. And when you manage a behavior, you can see that in the performance. How fast, how slow things are happening, right? And then in order to improve the behavior and the performance, there are a lot of things the company is doing. They train people, so they manage skills, and also they improve the knowledge base, right? So by doing that, we are basically improving the performance of the team. So when you improve the performance of the team, coupled with the systems and processes, you will be able to create customer value. Remember, on the top, we look at customer value determination. So what do we give to the customer? And then what do we actually build for the customer? And once you give that, we look at customer satisfaction. And we don't stop there. We do continuous improvement. Now, generally, continuous improvement is on the process. Right? So we continuously looking at ways in which we can improve our process. right? So these are some of the demands and issues, not just individually people are facing, but companies are facing. So what did we do today? So we looked at our question, which is how do we answer the question, is this software the best, right? Is this the best software? This was our question. Is this a good quality software? Now, to answer that, we looked at certain factors. So the most famous factor in this case is the McCall's factor, right? It has three things. And we took each one to look at and make sure that we can give the proper software to our customers. So in the meantime, we also realized there are two things that was required. One is measuring the attribute of the software, what you can see, and also monitoring the process, development process of the software. That is how you build this, right? That is quality assurance. So that's a difference between quality control and the quality assurance, right? And then we also looked at different definitions of quality. What is quality? And then we also realize, coming back to this is the manager's role, deciding what factors we are going after, selecting the standard, and then assemble everything in order to start the project, right? So this is what we discussed today. McCall software quality factors. All right, I guess that's all for us for today. And I, like last time, I also loaded many different things to the LMS. Please have a look at it and go through them. Some of them are videos. I have a nice video on the McCall software factor. Have a look at that. And also, I mentioned which chapters to read on the textbook. So go through that. You'll be okay with covering the topic. Any questions, anyone? No? All right. I'll see you soon then.